So this is just a very brief presentation that's going to give you some visibility to a relatively recent project in the European Union called MetroHall. It's funded by the European Commission and it's targeting a number of 5GPP KPIs, objectives, use cases. Now, my particular area of expertise is on the capacity provisioning and management, network optimization, usually involving multiple layers of connectivity in order to provide a variety of 5G services and applications. As we saw in the previous presentations there's things like extreme mobile broadband, ultra-low latency communication, critical communication for hundreds, potentially thousands of different types of services at varying differences of size and scale as well. So the project that, one of the projects I'm currently involved with is a multi-partner project, encompasses small, mid-size enterprises, operators, software, hardware vendors from the European Union, and we're kind of focused on that front haul technology, right from the radio interfaces, taking connectivity from the different devices, providing that capacity and connectivity across the front haul of the network through a variety of VNFs or compute and storage nodes where required, and then either backhauling it out to some public or private internet or other sort of data center site. So there's a vast variety of technology here, of course, that we need to consider. But one of the areas that's actually posing a significant challenge for us is network slicing. And this is a ubiquitous term which is incredibly subjective. And depending on which standards organization or technology area you're familiar with, you will have a particular definition of network slicing. Now, in the context of MetroHall and 5G, you can either look at network slicing on the radio side and sort of the spectrum assignment and also mast capacity and resources, or the capacity and connectivity and some of the functions that are actually providing or facilitating the service. Now, in a variety of organizations, we've tried to, this both closed and sort of open standards and specification forums, we've tried to define network slicing, and it's proving to be a challenge. There is no single view of network slicing. There's the 3GPP, ITU, IEEE, MEF, IETF. They all have a particular definition that they're working on. So let me just attempt to use a definition here, which is pulled straight out of a framework called ACTN. And actually, ACTN has already been mentioned a couple of times, including the previous presentation from SKT. ACTN is a method, a set of processes, a framework for abstracting the control and management and orchestration of transport networks. So these are typically traffic engineered high-capacity packet networks, absolutely multi-domain, either hierarchically speaking or horizontally speaking. And ACTN is it's an IETF framework. It's recently sort of come out of the oven and been assigned an RFC, so it's a formal definition. And what ACTN is attempting to do is provide that method of abstraction without prescribing particular sets of interfaces. But certainly for MetroHall, we need to take a set of logical links, nodes, whether it's end-to-end connectivity for point-to-point or multi-point or point-to-multipoint connections at a wide variety of speeds and guarantee performance, especially for ultra-low latency applications. And that's very hard to do with existing technology. We talk about overlay networking and VPNs. Well, this is not network slicing. This is, to the application, it may look like a slice of resources, but actually at the edge, that's not where we need the slicings or the guarantees. It's really across the core. So you can read the specification and the particular RFC. I've got it in a reference document. But ACTN is really taking a set of generic components and identifying how you would use these in a complex network to deliver sort of next generation control and orchestration. So we saw with SKT there actually that they have physical network controllers which are managing maybe horizontal domains of technology, and it may be open daylight. In this case, within Metro Hall, we're using Honors. But essentially those need to be coordinated because I need to provide end-to-end connectivity and capacity and specific network functions in order to deliver the service. And we already have a wealth of interfaces that are highly applicable here, whether those are sort of legacy technologies that might use code points and TLVs to actually set up and signal capacity or connectivity, or sort of emerging model-driven technologies. We saw RESTconf earlier and NetConf as a southbound interface with data modeling technology. But ACTN is agnostic to that. What ACTN is saying, well, this is the functional, or these are the sets of functional components that you need, and these are essentially how they will be coordinated in order to provide that sliced service. This CNC, and apologies for all the three-letter acronyms, but that's the world that we live in now. But this customer network controller is the consumption of connectivity, maybe that slice of network resources, which could actually be further sliced. There's no reason why we can't have a recursive model where you're providing physical or even logical connectivity in some cases through the MDSC. And we saw that on the previous presentation. So think of this as a supercontroller, maybe a transport orchestrator, to the consumer of the connectivity, the resources that are being assigned. And these may scale in and out over time as well. And of course, potentially you've got application-specific controllers that run on top. Now, why are we getting all excited about this architecture? ACTN is something I've spoken about 2 years ago at Layer 123. I'm one of the authors of the ACTN specification. What I'm trying to do now is kind of provide a clarion call for additional investigation and development work that needs to be done in order to continue to evolve ACTN and the ancillary technologies for projects like Metro Hall, which has a practical implication, but also SKT. We saw just in the previous presentation, this is an organization that's one of the world's largest operators, certainly mobile space. It's in the top 20 with a multi $10 billion revenue stream, and they're using this exact framework, this architecture, these types of interfaces to deliver those services. And as we can see here, there's a problem statement, requirements documents, use cases. They all feed into the ACTN specification. This kind of activity occurred 2-3 years ago. Now we're seeing the specifications actually become formal RFCs. More recently, in the last 12 to 18 months, we're seeing how the applications, the CNCs, will request, whether it's a point-to-point service or a network slice, how they can actually request that connectivity, the capacity, ensuring that specific service parameters are met in terms of latency, reliability, resiliency, as well as if we need an entire network, how the slice can be requested. So we're starting to see from not just the IETF, I know, apologies for some bias here, but there's a lot of IETF documents. There are other organizations that are providing candidate solutions. But essentially, we need to start thinking about how an application or a consumer can request a network slice, can request the service. And in order to deliver this brave new world of automation, we must have model-driven approaches. We need to use APIs, and we need to kind of stop talking about things like the marketing terms. Again, mentioned earlier, REST. Well, REST is a set of principles, but actually show me what it is that I can use. How am I going to apply the glue? What is that glue? What are those options that I can actually use? So there's things like the Layer 3 VPN service model. It's a relatively recent standard, as well as work in progress models for Layer 1 and Layer 0, and also virtual networks. The third area that needs investigation is how you combine connectivity service models. So without specifying specific technology layer that you're going to use, but this is what I need, and that's almost a declarative statement that gets mapped into some imperative model, also known as policy, so mapping intent to policy. We also need to combine this with virtual network functions. And this is not a very exciting presentation because I don't talk about VNFs that much. We seem to just take for granted that the network capacity can be applied, and actually we need to focus more on the orchestration and management control of the VNFs. Well, actually chaining the VNFs together, knowing where to instantiate them, how to size them, whether to choose a microservices architecture using containers or putting them in VMs. Well, actually, these are decisions that will be made by a machine, but they have to be requested through some kind of intent or declarative model. So I just want to highlight that as a project, we are building physical hardware, very sophisticated variable bit rate optical transport technology. We're embracing open source projects as well as more formal standards and specifications. But we have gaps, and those gaps are the service models. Because if you want to have inter-domain, inter-provider, interoperable networks where machines can talk to other machines, and through the miracle of automation, you can have end-to-end connections or network slices apportioned, then we need the relevant models. And this is a rather nice diagram, and again, it kind of maps to ACTN because that's one of the frameworks that we're using, but it shows how these models are used, and this is just for the service provisioning that may or may not include some kind of network function. There are another set of models that will be required for things like telemetry, maybe assurance as well, and in the need of some sort of degradation of service that may be more commercial degradation as a particular capacity network is increasingly used. You may have to switch between providers rather than sort of waiting for the lower layer, in this case a particular PNC, to optimize its MPLS or GMPLS or optical transport network. So let me just also highlight that what MetroHall, the project, is building is actually a commercially viable platform. These are proof of concepts, although the European research generally is looking at longer term projects and requirements and identifying candidate technologies. We should be clear that this type of architecture, and very similar in concept to SKT, would have commercial applicability. And this is a recent overview of a demonstration that was given at ECOC, which is one of our larger optical networking conferences very recently. And it demonstrates how an ACTN framework, so really an architecture, framework are all the available components, the architecture being which of those components and interfaces I'm actually going to use to solve my problem. In this case, we're using our sort of parent controller, so think of that ONUS Global as the supercontroller, the PNCs, which are responsible for each of those transit domains that I had on a previous slide, and also we saw in the SKT presentation, are sort of orchestrated through this parent controller or supercontroller to provide the end-to-end connectivity. Now, in this case, in this example, we've got things like data center fabric. So we could assume this is a radio access space, RAN, connecting into local data center connectivity. It will be, in this example, it was actually using OpenFlow. And of course, the higher layer controllers are agnostic to that forwarding plane. We don't care. We just need to meet a set of arbitrary attributes. The transport or the front haul of the IoT, IoE, 5G type applications may require connectivity to other parts of the network or out to the public or private cloud. So we've got some variable bit rate transponder technology, which is managed by another PNC, of course. Here is our physical network controller for the optical network, and then accordingly something on the other side of the network. And it just shows you sort of the relative series of messages between the components to set up a particular slice of resource. and you're more than welcome to click the link when you download the slides and actually see a much more detailed demonstration of this architecture in action. So as I kind of mentioned, and one of the things I wanted to do with this presentation was just kind of highlight some of the key areas that the project in its contributions to some of the more formal standards organizations, but also other open source initiatives, de facto standards, some of the areas that we're still sort of having to investigate and develop are clearly we need to continue working on service models. We need to look at the virtual network slicing model, how you would apply some kind of policy model to that. There are numerous ways of expressing intent, things like event condition action, general purpose, role-based access control, etc., ECA. There is unfortunately no coordinated effort across the standards organizations to develop an intent model for things like transport networking, whether it's 5G or fixed network. We also need to be able to signal and request a set of functions, and this isn't necessarily embracing YAML templates from the Tosca initiative as part of OASIS, but it's really considering also what the telco network connectivity will be as well. So there's definitely kind of a gap there. And then finally, and again to kind of point back to SKT, there's a need to be able to have active monitoring of the lower layers or the transport domains. So these are through sort of telemetry methods, whether you use gRPC and protobuffer or something that's netconf or even restconf based, because there are different time horizons that we're dealing with that you still need to monitor what's happening down in an optical transport network will have to be extracted through a variety of analytical models to something that makes sense to some higher layer network slice orchestrator. So there's numerous problems that need to be solved, which is all very exciting and interesting, and will keep our researchers busy. Good. So it was a kind of lightning talk because I wanted to try to bring back the session in order to give you guys some time for lunch. So if there's time for questions, I'm not sure. Otherwise, I will hang around for a few minutes at the end of this presentation, and feel free to come and talk to me or send me an email. So thank you.